Number 22 was a situation that it is a double angle substitution. Do you see how there's a big 2 here? That means double angle. If it was a square, that wouldn't be a double angle. That would be a... Actually, if it was a square and they were all cosine, it would be good to go, right? So where do I get this substitution value? I go to my reference sheet, and I pick up the one that's going to make my life easiest. And I'm going to pick up the one that's all cosine, which is 2 cosine squared x. It says a, but since this is x, I'm going to put an x here, minus 1. I wouldn't pick the one with sine in it, and I wouldn't pick the one with both cos and sine in it, because in order to solve this quadratic, they all have to be in terms of the same trig function. So now I have to distribute that negative, and I'm going to set this equal to 0 in the proper ax squared plus bx plus c equals 0. You can write let x equal cosine x and then put your a, b, and c here. I showed you that if you don't want to do that, that if you just wrote cosine x instead of x equals, it would be fine. So now, negative b plus or minus the square root of b squared minus 4ac. Put this into the calculator, I get a 9. Simplify our radical 9, I get 3. Break it up to negative 1 plus 3 over 3, negative 1 minus 3 over 3. And then I bring back the trig, which is cosine. So this is my negative 1 plus 3 over 3, which is 2/3. This is my negative 1 minus 3 over 3, which is negative 4/3. Now, because this is cosine, the maximum is 1, the minimum is negative 1. There is no angle whose cosine is negative 4/3, so that's a dead branch, that's a rejection. So for this first degree branch, we do QRA. We're looking between 0 and 360, because that's what the question told us. Quadrants 1 and 4 is where cosine is positive. The reference angle, I do second cos, 2/3, and I get 48. The angle answer in quadrant 1 is 48. The angle answer in quadrant 4 is 312, because I do 360 minus 48. And these are my two answers, which I can express in braces if I choose to. Make sure you use your degree symbol.